Humidity may affect COVID-19 outcome. How? As we move from a colder winter to a warmer spring, the outcome of the COVID-19 pandemic may significantly depend on levels of humidity, indoors and outdoors, a new review suggests. Professor Akiko Iwasaki, an immunobiologist at Yale University in New Haven, is a senior author of the paper which appears in the annual review of virology. As Professor Iwasaki and the co-authors note, seasonal cycles are known to play a crucial role in the transmission of respiratory viral illnesses. The common cold and flu reach epidemic proportions during winter. The key outbreaks of SARS-CoV-1 and SARS-CoV-2, the viruses that cause SARS and COVID-19 respectively, have also occurred in the winter. The link between viral outbreak and the season has been the topic of much research. According to the authors of the new review, the two main factors that contribute to the connection are the changes in environmental parameters and human behavior. Specifically, differences in temperature and humidity affect how stable and transmissible viruses are. For instance, some data reviewed in the new paper suggest that cold, dry, unventilated air may contribute to the transmission of influenza in the winter. 90% of our lives in the developed world are spent indoors in close proximity to each other. What has not been talked about is the relationship of temperature and humidity in the air indoors and outdoors and aerial transmission of the virus, says Professor Iwasaki. In the paper, she and the team explain how winter's cold, dry air may affect the transmissibility of the new coronavirus. How dry air affects immunity, viral spread. First, they say that when cold, dry air comes indoors and is warmed, the relative humidity indoors drops by about 20%. Such a drop in humidity makes it easier for airborne viral particles to travel. Second, the hair-like organelles outside of cells that line the body's airways, called cilia, do not function as well as in dry conditions. They cannot expel viral particles as well as they otherwise would. For instance, the new review cites one study that found that mice in an environment with 10% relative humidity had impaired clearance of the influenza virus compared with mice in an environment with 50% relative humidity. Furthermore, studies have shown that dry air exposure of mice impairs epithelial cell repair in the lung after influenza virus infection, according to the news analysis. Lastly, the authors point out several studies in mice have shown that the immune response to viruses is less efficient in drier conditions. For instance, one study found that rodents in environments with 10 to 20% relative humidity succumbed to influenza virus infection more rapidly than those housed in 50% relative humidity. 40 to 60% humidity may be ideal. However, the researchers note that too much outdoor humidity can also support viral spread. For instance, in tropical areas, airborne droplets that contain the virus fall on indoor surfaces, where the virus can survive for longer periods. Many homes and buildings in these areas are poorly ventilated, and people often live in close proximity, and in these cases, the benefits of higher humidity are mitigated. Professor Iwasaki says, the researchers emphasizes that People can transmit the virus at any time of the year through contact with one another and contaminated surfaces. The new findings apply only to airborne transmission. It doesn't matter if you live in Singapore, India, or the Arctic. You still need to wash your hands and practice social distancing, cautions Professor Iwasaki. That said, the review concludes that studies in mice suggest that a relative humidity of 40 to 60% is ideal for containing the virus. That's why I recommend humidifiers during the winter in buildings, says the study's senior author. Other studies in mice also found that an environment of 50% relative humidity contributed to good viral clearance and an efficient immune response.